We're doing revision of mathematics paper 1. Let's go to our next question. All right, so this is question 4.2, which is obviously based on functions. You see, inverses and functions is one of the most challenging topics or concepts that you have to work with when you are in paper 1, right? So it reads as follows. It says the graph of f of x equals half of x plus 5 squared minus 8, and g of x is half of x plus 9 over 2 as sketched below. Bullet point 1, A is the turning point of f. Okay, that's key information. We know that A is the turning point, all right? And then the axis of symmetry of f is of f intersects the x-axis at E. So what line are they talking about now? I'll draw that line in blue. They're talking about this line here. This is the axis of symmetry. Remember, the axis of symmetry is a line that will divide your graph into two equal pieces, right? It just splits the parabola into the left piece and the right piece. So please pay attention to that. Apparently that line cuts the x-axis at point E, right? And the line G at a point D, okay, there's a point D there with coordinates M and N. C is the y-intercept of f and g, which means the graph of f and g, they share the same y-intercept, okay? Very important information. Right. Now, from what is given to us, this love letter, before we even look at the questions, there's a lot of things that you guys need to know about either the defining equation of the graph of f, which is a parabola, and the straight line g of x, which is half x plus 9 over 2. For example, if I look at the parabola, just the parabola alone, okay, this part of f, the f of x graph, the number 5 and the number -8 are important numbers, right? They, in fact, give you the coordinates of the turning point. So these are some of the things that you need to know before you even start answering the question. You need to know that point A is the point where the graph turns. So the coordinates, if you're looking at a graph of A equals to A into x minus p squared plus q, the p and the q will always give you the coordinates of the turning point. And in this case, 4.2.1 is asking us to write down the coordinates of A. Immediately, you can tell that A is going to be the point where x is -5 and y is -8. Remember, the x coordinate will always be the opposite of what you're looking at inside that bracket. If it's a plus, you'll write a minus, and if it's a minus, you'll write a plus. But the y one, the one of q, the -8, you take it as you see it. That's going to be -8, the y coordinate of the point A. Right? And like I said before, when we ask you to write something down, it means it is somewhere in front of you. Either it's a straightforward question in the sense that it is too easy, that everybody knows that, or you're looking at it somewhere in front of you on what you are working with. Very important. Okay, so the answer to question 4.2.1, the coordinates of A, you just simply write them down. It will be -5 and it's going to be -8. Now that's what I see immediately when I look at the graph of F. And when you go to the graph of G, the graph of G, the straight line, okay? It's in the form y is equal to mx plus c. So some of these things, you see them by just looking at the equation. What does that mean? That means I can immediately write the coordinates of c, the y-intercept, because the last number, 9 over 2, gives you the coordinates of the y-intercept of your graph. So immediately, I know that the coordinates of c, the x will be 0, and the y value is going to be 9 divided by 2, right? So just keep that in mind. It might be useful later as you keep going and answer your questions. Okay, cool. So 4.2.2 is asking us to write down the range. Write down the range of the graph of f. Now, what is range? Well, range is just simply asking you what are the y values that are covered by the graph. Remember, domain, we're discussing the x values covered by the graph, but range, we're discussing the y values that are covered by the graph. Where do we see the graph on the y-axis? Where does it start and where does it end? Okay, there's somewhere where it begins and somewhere where it ends. Okay, now let's go to the graph of f. The graph of f is the parabola. You'll agree with me that this parabola starts at point A. This is the smallest possible value you can get on this graph. So that's the minimum value of the graph, right? The y value for that point is -8 thanks to the coordinate of A, since that is the y coordinate. Okay, that's the minimum value, the y coordinate of the turning point. So this graph starts here and goes all the way up, 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 up until the second coming. Okay, it doesn't stop anywhere, it goes up forever and ever. So what we're simply going to do is say the y values from -8 to infinity will actually give you the range. So you can say y is all values that are bigger or equal to negative 8. This is one way of putting it. Alternatively, some people prefer to put it this way. Y is the element of. Then you have to put the smallest possible value that it gets to. In this case, it starts at negative 8. And how far up does it go? It goes all the way to positive infinity. Now let's discuss the brackets that you would use. Since the graph does get to negative 8, we're going to use a square bracket. This bracket means including, okay? This including, it includes negative 8. It does get to negative 8, but it does not get to infinity, so we don't use a square bracket. In case we use this kind of a bracket to indicate that it keeps on going closer and closer to infinity, but it will never get there. Very important. Okay, let's go to the third one, 4.2.3. So 4.2.3 says calculate the value of m and n. Okay, calculate the value of m and n. So what is this m and n? Well, those are the coordinates of point D, right? Now, the only thing I know about that point D is that it's a point on the straight line, okay? So the straight line knows everything about its points, okay? The straight line knows everything about its points. So this is a straight line. Point D lies on the straight line, right? Now, it means the following. If I know any of the two coordinates, I can just substitute in the straight line. The straight line will help me to get the other missing coordinate. If I have got the x, I can type it back, it will give me y. Or if I have y, I can type it back, it will give me the x coordinate. So let's see what we know so far. The other thing that you need to remember is this. Along a vertical line, all x values are the same. X values anywhere along the vertical line will always be the same, right? So let's see what we have so far. We know for a fact that point D is not only on the straight line, graph of G, it also lies on the axis of symmetry of the parabola, the blue line, okay? Because it lies on that blue line, it means all the x values on the blue line are going to be the same, okay? That means even at point E, since point A has an x value of negative 5, right? We did find that the x value at A is negative 5. It means the x value at E will also be negative 5, and the y value is obviously 0 because E lies on the x-axis. Similarly, I'm expecting the coordinate of D, this number here, must also bear the same x value, so it's also going to be negative 5. So the m value will obviously be negative 5, right? Keep that in mind, very important. So immediately, by just observation, we can see that m is equals to negative 5. Why? Because all x values on the axis of symmetry should be the same. X at A is negative 5, x at E is negative 5, and x at D will also be negative 5. It's always the case. So you understand that if you go up, straight, vertically up, all the x values will be the same. They will all be the same because they all above A, okay? That's why m, the x coordinate of D, becomes negative 5. All right. Now, how can we use this to figure out the missing coordinate, which is n? Remember they said D, okay, which we now know is actually negative 5, and n is on a straight line, which is g of x. It lies here. It's on this line. Okay, with the equation of g of x is simply half x, right, plus 9 over 2. Now, what I'm simply going to do is I'm going to sub this minus 5 wherever I see x, right, and then that should help me figure out what n is. N is the y coordinate, so n equals to half of what? Of x plus 9 over 2. But what is my x value? Well, it's simple. It's just going to be negative 5, okay? Then after that, we just do basic arithmetic simplification here. We're going to have 9 minus 5 over 2, which is going to give us 4 over 2, which is simply going to be 4. Therefore, when m is negative 5, the y coordinate, which is n, is just simply going to be 4. And that's the value of m and n. Now remember, they didn't ask for the coordinates of D. They just said find m and n. If they said find the coordinates of D, you'd have to find m and n and put them again in point form using D as well. Put them in point form, in coordinate form, if they're asking you to put them in coordinate form. Awesome question. Okay, cool. Let's go to the next one. Right. So the next question, which is question 4.2.4, is actually very interesting. We're asking you to calculate the area of OCDE, okay? Calculate the area of OCDE. Now, allow me to remove what I have here so that the diagram is a bit cleaner and then you guys can see the analysis with me. So first of all, let's find this OCDE that they're talking about. Where's O? O is this point here. C is this one here. D is there. And then E will be you moving down. So it's creating a quadrilateral. There's a quad here that is matching, all right? An awesome quadrilateral. We are interested in finding the area of this quadrilateral. Now, I'm going to redraw this and then we're going to zoom on it, right? Because I want you guys to see what is going on, all right? But before we get there, let's just put what we know so far. The first thing that we know is the coordinates of D, right? The coordinates of D is 2. N is 2. We found D with coordinates -5 and 2, okay? Now, if N is 2, it means the movement from the x-axis to point D, as you move up from the x-axis to point D, you are actually moving how many units? You are moving 2 units up, okay? Because D is exactly 2 units. That's what the distance of the length, the side DE is going to be. It's going to be 2 units because you're moving from the x-axis to point D, you're moving 2 units, right? That's the first thing that I want you to know. Secondly, from O to E, we are starting at the origin, we are moving to E. What did we agree on? We agreed that the x value here is actually -5. But we're discussing geometry, so negative does not work in that case, right? It means the length of this side from O to E, the entire distance, okay? Let me use a different color. The entire distance will just be 5 units as you're moving from O to E. You're moving 5 units from O to E, and you're moving 2 units going up. Now, from O to C, we need to know what is the y value here. And we did discuss that this y value is the y-intercept of both the straight line and the parabola. And we did find it as 9/2, so that's actually 4.5, okay? 4.5 and 9/2 is the same thing, all right? So that's what we know so far. We know that the distance here is simply 4.5. We know the distance from O to E is 5 units, and the distance going up is actually 2 units from E to D. So I'm going to redraw that, and then we're going to look at it and see how we can calculate the area of the entire geometric shape. All right, okay? Let's try and see how that's going to pan out. 4.2.4, right? Let's see how that is going to pan out, all right? So it's important for you to also understand that you are allowed to mess up these things. You can actually try and redraw it and simplify it by analyzing what is going on, right? So what do we know? We know the shape of this thing. Allow me to draw it again so that we can see it. This is how it looks. This is how it looks. This is how it looks. There's D here. There's E here. We've got C here and we've got O here. What do we know so far? We just established that the length is 5 units going this way. We just established that this length is actually 2 units going that way. And then this is actually going to be exactly 4.5 units because the coordinates of C are 9/2. But now we want the area of this. This is going to definitely be parallel to the x-axis. It's the axis of symmetry. DE lies on the axis of symmetry, so that line is parallel to this. So we know that we've got a corner here. We also have a corner. We've got 2 options. We can use the area of a trapezium, or we can just divide this into 2 pieces. So that we've got 2 shapes, a triangle, and we also have what? A rectangle. Now let's try and find those individual areas and then add them as the total area of the geometric shape we're looking at. So the area of a rectangle, we all know this, it's length multiplied by the breadth. Length in this case is 5 units, and the breadth, which is 2 here, it will give us 10 square units, okay? 10 square units, that's the area of the rectangular part. Then we've got another piece, which is a triangular piece. The area of a triangle is half base multiplied by perpendicular height, all right? Half is a number, we all know that. What's the base of this? The base of the triangle is obviously going to be 5 as well, okay? But the height, let's discuss the height. If I want this to be a rectangle up to this point, it means I can divide the sides to 2 pieces. That has to be 2 because the opposite side is also 2. Now, if you're cutting 2 out of 4.5, that means the height of the triangle has no choice but to be 2 halves, right? Okay, 2.5. So it's going to be multiplied by a height of 2.5, and then you can just work out the answer to this, which is going to be half of 5. Half is 0.5 times 5 is 5 times another 2.5. There's 2.5. We get an answer of 6 1/4, which is as good as 6.25. So we're going to have an answer of 6.25 square units, okay? Now that means the total area that we're looking for. Therefore, area is going to be the sum of the 210 and 6.25. That is 16.25 squared units, okay? Very important, very, very important. Simple question and exciting at the same time. It allows you to see how you can use your other concepts to answer these kinds of questions. Very, very simple. Okay, cool. Let's go to the next one. The next question is 4.2.5. We are being asked to determine the equation of g to the power -1. That means the inverse of g in the form y equals to something, right? Now, what is the procedure of finding the inverse? Well, you rewrite the equation with y equals to, and then you swap the x and the y. We have to take the graph of g. What is g? G is a straight line. We know the equation of g. It was given to us as half x plus 9 over 2. So we're asking you to find the inverse of that. Right, cool. So quickly, let's see how that is going to pan out. We're looking for the inverse of g. The question is 4.2.5. Right? Now, g of x was given to us as half of x, right, plus 9 over 2, okay? So g of x is as good as y. So y is half of x plus 9 over 2. We are asking you to find the inverse. Now, to find an inverse, the first thing you do is you interchange the x and the y. Where you see x, you put y, and where you see y, you put x. Everything else stays the same. You don't change anything, except that you interchange the x and the y. Our x is now a y, and our y is now an x. And then after, you then make y the subject of the formula. Very simple process, okay? Now, I don't like working with fractions, so I'm going to double everything. Let's double everything. You double the left, you get 2x. You double a half, it becomes a 1. You double 9 halves, you get exactly 9, right? So eventually, we end up with an equation that says y is 2x minus 9. Now, this is the equation of the inverse of g of x. They asked you to write it in the form y equals to something, and that is how you find the equation of the inverse. The last question of these ones, they're asking us quickly to answer something very exciting here. Now, this is actually a nice question because it involves another concept which is called differential calculus, right? So it says to us, if h of x equals to the inverse plus some constant is a tangent to the graph of f, determine the coordinates of the point of contact between h and f. Now, I don't know about you grade 12s, but it is very difficult to answer something that you don't see. So one of the things I want to encourage you to do all the time is if you see a lot of words that are trying to describe a situation, right, try to take those words and convert them into a picture. It is easier for you to solve a question if you can see what is going on, right? These are it's a lot of words, a lot of things that are going on here. There's an inverse, there's a k, there's a tangent, there's a lot of things going on here. They're asking for the point of contact. If you don't see this, you will not be able to work with it effectively, right? So I'm encouraging you every time there's words, try to convert them to a picture and then see what is going on. Then that will help you to analyze the question much better. All right, so let's take this and re-look at this. Let's go back and try to see what this is all about, okay? So they're saying to us here, we need to find, okay, let me remove this so that you guys can see what is going on. What do they mean, these people? They're saying this is actually a tangent, okay? The tangent is a line that is going to touch your curve at one point, okay? Now, let's try and write the equation of this h of x. They are saying to us that h of x is the inverse graph of g plus some constant k. Remember, this is just a movement up or down. Up or down. It's just shifting the inverse graph up or down. So let's go and check this inverse. Where is this inverse? The inverse, we just found the equation of the inverse is 2x minus 9. Okay? We know that this is 2x minus 9. So 2x minus 9 plus some constant k is going to be the tangent to this graph of the parabola, okay? So where is it? I'm just interested in the number 2. I just wanted to see the number 2, why? Well, that's going to help me to see if this is going to be an increasing tangent or a decreasing tangent. So what I'm sure about is this is the line that we're talking about. This line is going to touch the curve at one point. So that's why it is a tangent. So I'm going to draw it. Let's try and draw the picture of this so we have a better idea of what is going on. So this is what I have so far. I've got a tangent. They're asking us to find the coordinates of the point of contact. Now, that means they want to know if this is point P, what is its x and its y value? That's what they're just asking us to figure out, right? Now, I see the picture, I understand. So what I want you to know is at the point of contact, the gradient of the parabola will be the same as the gradient of the straight line. Keep that in mind. The gradient of the parabola will be the same as the gradient of the straight line. That's what is going on at the point of contact. Keep that in mind. Very important. Okay, so that's my line of departure as I try to answer this question. 4.2.6. Okay, if you're dealing with a graph, which is a quadratic function, and its tangent at the point of contact, what is true between them is that the gradient, okay, of the graph of f will be the same as the gradient. They have the same gradient, okay? will be the same as the gradient of the graph of h. They're calling it h, so that's actually what is going on. Now let's find the gradient of a parabola. The gradient of the straight line is easy. Okay, we just found that this graph of h has the equation h of x equals 2x minus 9 plus k. Now, since k is a number, which is a constant, we can clearly see that the gradient of this is just going to be a 2. So I'm just going to take this and throw it there as the gradient of the graph, which is h. Now, the problem is finding the gradient of the parabola. Parabola is not as easy as a straight line. We need to go back and find the gradient of a parabola. Somebody's asking, how do you find the gradient of a parabola? Well, the gradient of a parabola will be the derivative of that parabola. So the derivative gives you the gradient function. That gradient must be equal to 2. So let's find the derivative of f, and then we can be able to finish off this question. Now, I have a problem. My graph is not in a nice way to factorize, so we're going to have to do some engineering first before we can find its derivative. Okay, let's write it in white. Okay, so f of x was given to us as half of x plus 5 squared. I think it was minus 8, okay? This is what the graph of f is. So we need to find the derivative of that. It's not in the right form to derive, so I'm going to have to break the bracket. It's going to be x squared plus 10x plus 25. This is how you square a binomial, minus 8, okay? Then we come with half. We get half of x squared. We get plus 5x, and then you get 25 over 2 minus 8, right? And then eventually, you end up with half x squared plus 5x. Now you want 25 over 2 minus 8. What is that going to be without making mistakes? All right, that's going to be 25 over 2, 25 halves. Okay, we need to remove what? We're subtracting 8 from that. We get 4, it's 9 over 2. Oh, yes, 9 over 2. I was expecting this 9 over 2 because remember, the straight line and the parabola are sharing the same y-intercept, so they should have the same c value. Okay, so I just converted my f of x into this form. Why? Because I'm looking for the derivative, right? I'm looking for the graph of the gradient or the gradient function. This is what it is. You always multiply the exponent to the coefficient. So exponent times coefficient. 2 times half is a 1. X to the power. On the old exponent, you just subtract the 1. You're going to get a 1. Again, a new exponent here is 1. 1 times 5 gives you 5. Okay, x to the power 1 minus 1, which becomes a 0. Anything to the power of 0 is a 1. So eventually, we end up with a number x plus 5. The derivative of a constant will always be a 0. If you've got a constant, when you derive it, it always gives you an answer of 0. So the derivative of that becomes just x plus 5, okay, which I'm going to now take and paste here. So what does this mean? That means x plus 5 is equal to 2. So x will be negative 3. Okay, I've got negative 3. But they said they want the whole point. I have negative 3, but you know if you've got an x value, to find the corresponding y value, just substitute this in any of the graphs. I can't use h, beautiful people. What is bad about h? What is bad about h is I don't even know what is this k, right? So even if I plug my negative 3 here, what is negative 3 times 2? It's going to give me negative 6 minus 9, but I've got a problem. There's k there. What am I going to do with this k? You see what I'm saying? That's why it's important for you to understand. You can use either the parabola or the line, but the line is not useful in this case. We don't know what k is. So we'll just take this number and plug it in the graph of the parabola. Then you're going to get your answer from that. Very awesome. Okay, so let's see. I'll plug this in the graph of f. So that means my y will be half of x, which is negative 3, added with 5 squared minus 8. Okay, let's call the calculator to assist. Please come and help us. What's the answer to this? Right, so half is 0.5. I'm being lazy, so I'm going to just type that. Negative 3 added with 5, close bracket. You've got a square there, and then you need to subtract 8 from the result. You end up with an answer of negative 6. Okay, cool. So I'm ending up with an answer of negative 6. So that means the point of contact is the point negative 3 and negative 6. And you also have to check, does it make sense that the coordinates where this graph is going to, where this tangent is going to meet the parabola, has both negative x and negative y value? If you go back and you look at the drawing, you will see that yes, it lies in the third quadrant, which is where both x and y are negative. And then you'll eventually say, yes, the answer is going to be negative 3 and negative 6. And if they ever asked you to find a k value, you could then take those x and y coordinates and substitute them in the equation of h of x. You will then be able to figure out what the value of k is. But they just wanted the point of contact. We just gave them the point of contact without any problems. And this is how you would work out the solution to this problem.